Hi, welcome back to our Algebra 1 video series. On the 1.3 lesson video, we're going to take a look at solving equations with variables on both sides. There are a couple of general rules that we should try to follow as we're solving these equations. Number one is that if you have a variable term that's isolated, leave it alone. I want to get my variable terms isolated or by themselves. So if you already have one that's by itself, that's great. Don't move it. Find another variable term on the other side of the equal sign that I can move instead. So here, this one is not isolated. It has another term with it, in this case a 12. So I'm going to do the inverse or opposite operation to move this to the other side of the equal sign. I didn't move that negative 6x because it was isolated. It's by itself, so why move it? Here I have 3 minus 6, or negative 6 plus 3. Well, 3 minus 6 is a little bit easier for my brain to work with, and 3 minus 6 is a negative 3. So because I wanted this variable term isolated or by itself, and I already had one that was isolated or by itself here, I'm not going to move that because that's good, that's what I want. I'll move the one that's not isolated. And now it's a one-step problem. I see multiplication, I'll divide, and x would be a negative 4. All right, why don't you take a look at number 2? You will get a decimal answer, but that's okay. A common error that I see all the time here is that students would not use the inverse operation. They'd forget to do the opposite of negative 5x. So oftentimes I'll see this error where a student would go, well, negative 5 and positive 5, that's 5 minus 5, that's 0. So I have 0 z's. And then I try to divide by 0 and I run into some problems there. Just remember to use your inverse operations or opposite operations, and z would be 1.6. Now on 3 and 4, I've got some parentheses. So let me simplify that real quick. I'm going to multiply 3/4 by both of these parts here. I'll multiply 4 by both parts on the right side. And on number 3, I'll multiply 3 or distribute that 3 to both parts. And if you want to use 0.75 instead of 3/4 or 3/4, that's fine as well. And then once I've got that distributed, then it's just a nice two-step operation. So why don't you try pausing the video here, solving 3 and 4, and then unpausing to check your work. Alright, so what we've got here is a two-step operation. 54 equals 3k. If I divide, k would be 18. And here, I've got variables on both sides. So what I need to do now is I need to combine my like terms. Now, if it doesn't matter because neither one is isolated, if both variable terms are not isolated, usually I try to get rid of the smaller one or get rid of any negatives because that will allow me to avoid negatives later on. So I'll get rid of that negative 12x. And 8 plus 12, I'll get 20x. And if I want to isolate that 20x, I need to undo the positive 16. 20 equals 20x, or x would be 1. All right, 5 and 6, same idea. We're going to try to undo or remove the smaller of the variable terms. But first, I need to combine some like terms. I've got 2q and 1q on that side of the equation, so 5q plus 6, and since they are on the same side of the equal sign, I can just combine them into a 3q. Same thing on number 6, I've got a positive 6 minus 10. So I have to combine these, just add them up, or 6 minus 10. So you get 8 minus 4x equals 16 minus 8x. And again, let's pause the video. I'd try 5, 6, 7, and 8, and then unpause to check your work really quick, and then we'll move on. So here I get 2q is negative 8. Q would be negative 4. And here I would get 4x is 8, or x is 2. Now 7 and 8 are a little bit weird. 8's the weirder of the two for sure. When I go to simplify these, I'm going to undo the smaller variable term to avoid some negatives. So 3a minus 4 is 5, or 3a is 9. So a would have to be 3. And our last one here, this can be a little bit more challenging. I see a negative 5x, I need to add 5x. Well, hold up, 5 minus 5, that's 0x. Well, 0x, I don't even need to write 0x. But here I get a false statement. That's not true. Negative 10 or negative 30 is not equal to 10. We're going to see in just a second how do I handle a problem that gives me a false answer. Check that out in 1.3 part 2.